When introducing entities, Steve and I talked about objects that were defined by a thread of continuity and identity, not defined by their values. So what about objects that are defined by their values? These are called value objects, and they play an equally important role in a domain model as entity objects do.
A value object has very specific characteristics. It is an object that is used to measure, quantify, or describe something in your domain. Rather than having an identity key, its identity is based on the composition of the values of all of its properties. Because the property values define a value object, it should be immutable. In other words, you shouldn't be able to change any of the properties once you've created one of these objects. Instead, you would simply create another instance with the new values. If you need to compare two value objects to determine if they are equal, you should do so by comparing all of the values. Value objects may have methods and behavior, but they should never have side effects. Any methods on the value object should only compute things. They shouldn't change the state of the value object, since it's immutable, or the system. If a new value is needed, a new value object should be returned.
A value object that you probably use all the time is a string. In .NET and many other languages, a string type is immutable, and you now know that immutability is one of the key attributes of a value object. A string is a collection of characters, and the combination of all those characters give that string meaning. For example, CAR in English, a car. If a string were mutable, we could change the R to T. Now the string is CAT, a cat, which has a very different meaning than a car. Or we could add a letter, maybe put an S in front of it, turning car to scar, also completely changing the meaning of car. But it's not just the array of characters that gives a string its meaning. The order of them is also critical. Just think of the word dog, D-O-G. Shifting its letters around gives us something with a very different meaning.
So one of the things that .NET makes it really easy to do is to modify strings. Like you can change the length of it or make one all uppercase. But when you call, for example, toUpper on a string, it doesn't just change that string object. It gives you a new instance of a string that now has all uppercase characters.
I've heard many developers say that monetary values in financial systems have been perfect candidates for value objects in their system. And Ward Cunningham provides us with a really helpful example, a company's worth. If a company is worth $50 million, that means something, $50 million. It's a very specific measurement. 50 million on its own is not a measurement. It has no meaning without the unit, which in this case is dollars. In fact, dollars doesn't really help, does it? Because is it US dollars or Canadian dollars, Australian dollars? But US dollars alone doesn't describe worth either. It only makes sense when you put the two together as 50 million US dollars. There's actually one more factor to take into account, is the point in time of this $50 million, because of the way financial systems work and the fluidity of monetary values.
So we could still just have the two properties in this company class, but by creating a value object, you also protect and constrain the measurement. So for instance, we might have a class called company. It might have one property that was a decimal that was the worth, and another property called the worth unit that might be a string that says US dollar. The problem with this approach is that it doesn't tie these things together in any way. Nobody should be able to set the unit without also setting the amount. They should change together. More importantly, nobody can just randomly change the units. 50 million rupees is a totally different value than $50 million. The value is represented by the object as a whole. It's immutable. If the company's worth changes, then we can just set the worth property to a brand new worth value object.
A value object is not always for a measurement, though. It can be another type of description. I've used this one often, date time range, and it was perfect for the vet appointment scheduling app. We usually set a start and end time together, and can't really set one without the other. Also, we often need to pass the two values, start and end time, around from one method to another. So we've encapsulated them in a value object called date-time-range. The properties have private setters, which makes the object immutable since we can't change them. We aren't showing the full logic of the class here, but when we look at the value objects in our application, you'll see more of how we implement a value object in our software to ensure that it meets all of the attributes, not just immutability, but how we handle equality comparison and other logic.
In his book Implementing Domain-Driven Design, Von Vernon recommends that we should try to use value objects instead of entities wherever possible. He says, "It may surprise you to learn that we should strive to model using value objects instead of entities wherever possible. Even when a domain concept must be modeled as an entity, the entity's design should be biased towards serving as a value container rather than a child entity container." What this means is that you'll find that your design will have a number of entities who have very little logic of their own, or very few primitives as their properties, but instead will have a number of properties that each are themselves a value object.
So he's not saying everything should be value objects, but that it's probably our natural instinct to start by thinking of things as entities and then maybe once in a while go, oh, maybe that should be a value object. So what Von is suggesting is really start by thinking every time, should this be a value object? And you will surprise yourself at how many times something that you originally might have thought of as an entity really does make a lot more sense as a value object.
Or sometimes when you're looking at an entity, there might be a couple of properties that seem to always go together. You might be able to bundle these properties into a single value object.